Hi everyone, my name is Rick van Bruggen from Neo4j, and this is the third demonstration video that I'd like to show you guys on the contact tracing use case. We've actually done quite a bit of work already, right? We've imported the data set, just like we did in the blog post, right? Based on the Google Sheet, we've imported the data, right? Then once we had that, we were able to do a bunch of queries, right? Interesting queries to establish the risk, the potential risk of people and places. But now in this next little part here, we'll do a little bit of graph data science on this data set, this synthetic data set, right? In order to do that, we need a little bit more information. We need a new type of data to be added to our data set. Right now, we have people visiting places, right? That's basically the data that we have. But we would actually like to add a new inferred relationship to this data set, which is essentially based on the queries that we had in the second part of this video series. It's basically the overlap time or the meeting between different people at different places, right? If a person overlapped with another person during their visit to a particular place, then we are going to infer that this person has met this other person, right? And we're going to create a meets relationship between person one and person two, right? And this meets relationship is going to allow us to do a lot of interesting things in terms of graph data science, because many of these graph data science assignments actually require a monopartite graph, right? That means one type of node categories that should be part of the graph. The first algorithm that we'll run here is the PageRank algorithm. And actually, I'm going to just show you how that's done. It's super easy. But I'd like to also show you how this is created, right? We do this using something called the Neuler tool. Neuler is a little bit of a front end that allows you to explore some of these graph data science algorithms really, really easily. You start it as a graph app, right? So it's over here, right? If I just click this, then I get the Euler front end. And here I can start experimenting, right? I can basically say, okay, I want to look at centralities, I want to look at page rank, and I want to, look at any kind of label or any kind of relationship. I can play around with this, right? I've already done this for the contact tracing use case, so we don't need to go through this, but I highly recommend that you take a look at this tool set in order to explore the graph data science library. In our case here, all I need to do is run the PageRank algorithm here. I've prepared the code for it. There's a couple of configurations that I'm adding over here at the top, right? And here at the bottom, I'm just calling the algo, right? And writing back the information back into the graph as a property on my nodes, right? So if I now go back to my person nodes, right, then you will see that the person here, Juliana Wade, actually now has a PageRank property, right? There's another one here, right? Another one PageRank property. Some of them obviously are the same. That's perfectly normal. But we've actually added this property now to the graph, and we can query it as well, right? So we can basically say, okay, show me the PageRank properties, right? You can see that Beatrice Dickerson has a very high PageRank, which tells me something about her importance in the graph. How is she connected to the rest of the graph? Well, PageRank is telling me that I probably want to be paying attention to her. The betweenness property here is still, that was a wrong click. The betweenness property over here is still empty, but we'll change that in a couple of seconds, right? So that's the PageRank capability here. You can also look at this visually, obviously, right? And I can run a query here that gives me the PageRank, the most interesting nodes from a PageRank perspective. And I can explore this as well. If I have a little bit more domain expertise, I could probably make a little bit more sense out of that. The next graph data science algo that I'll be using is the betweenness algo. It's super comparable. This is one of the beautiful things of the graph data science library, is that the execution of this library or the use of this library has been made extremely consistent, right? So all I need to do is have a couple of parameters here at the top and then say, okay, I call this algo, right? And immediately after, all of the properties have been added, right? And I can actually explore that and find out that the Graph Data Science library has written these properties back into the graph, right? So now all of a sudden I have a combination of page rank, right, giving me a general indication on the importance of node inside the graph, and betweenness, giving me an indication of, how important these people are to the flow of information through the graph, and I can basically use that as well as a metric to find out more about the structure of the pandemic, really, right? So there's some interesting stuff there. Um, I'm going to do one more thing here, which is basically community detection. In order to do that, I need to change one property around, right? I'm going to be using the Louvain community detection algorithm, and that uses weights on the relationships, right? So the meets relationship that we created at the start of this video, we actually want to have a weight on those relationships. We already have that as a meet time duration property. But in order to use Louvain, I need that just as a number, right? So meet time in seconds, right? And that's a simple operation, as you can tell, right? Now I can run the algo, right? Boom, that's already done. And then I can actually take a look at all the different communities, right? How many communities have I got? I've got 30 communities that have been detected, right? And these are the number of people that are part of those communities. Now, obviously, then I can start exploring that again, right? I can start figuring out whether or not some of our policies need to be targeted at these communities, yes or no, right? So that's an interesting one. And with that, I'm going to finalize this video as well. And hopefully that was an interesting introduction on how you can use graph data science to know more about the structure of a contact tracing graph. And I hope this was useful for you. Thank you so much. Have a nice day.